So we were discussing about this coefficient of friction, and you note down this formula in your notebook. Write on the title: variation of F for laminar flow. Variation of F for laminar flow.
Hello, sir.
Yes.
सर तुम्ही स्टार्टिंगला जे एक्सप्लेनेशन केलं ते ऐकू आलं नाही नीट.
ऐकू आलं नव्हतं का?
नाही सर,
हा
क्लिअर
नव्हता आवाज, ब्रेक होत होता आवाज.
Okay, once again I will repeat it. See, F जो आहे that is called as the coefficient of friction. This coefficient of friction, it varies from for different pipes. Okay, and for the viscous flow, how to find this coefficient of friction? So this is the formula. It is used to find out this coefficient of friction for that particular pipe. प्रत्येक पाईपचा किंवा सरफेसचा जो कोएफिशियंट ऑफ फ्रिक्शन जो आहे तो वेगवेगळा असतो. अँड दिस फॉर्म्युला इज अप्लिकेबल ओनली फॉर लॅमिनार फ्लो ऑर विस्कस फ्लो. जर टर्ब्युलंट फ्लो असेल तर टर्ब्युलंट फ्लोसाठी कोएफिशियंट ऑफ फ्रिक्शन फाइंड आउट करण्यासाठी वेगळा फॉर्म्युला आहे. ज्यावेळेस आपण टर्ब्युलंट फ्लो बघू त्यावेळेस आपण तो फॉर्म्युला त्यावेळेस मी तुम्हाला सांगेन. जर पाईपमधून जर फ्लो होत असेल, पाईप फ्लोसाठी लॅमिनार फ्लो असेल, the flow, viscous flow taking place through the pipe, then we should use this formula to find out this find out the coefficient of friction. Now how to know that whether flow is viscous flow or turbulent flow? By using Reynolds number. Okay, सगळ्यात अगोदर रेनॉल्ड्स नंबर काय करायचं त्या ठिकाणी फाइंड आउट करून घ्यायचा बाय युजिंग फॉर्म्युला RE इज इक्वल टू रो VD अपॉन म्यू. हा फॉर्म्युला याच्यामध्ये रो ची व्हॅल्यू टाकायची, वेलोसिटी व्हॅल्यू टाकायची, डायमीटर आणि डेन्सिटी या व्हॅल्यू टाकल्यानंतर आपल्याला जो रेनॉल्ड्स नंबर भेटतो, समथिंग रेनॉल्ड्स नंबर जो भेटतो, इफ दॅट रेनॉल्ड्स नंबर व्हॅल्यू इज लेस दॅन 2000, देन वी कॅन से दॅट द फ्लो इज विस्कस फ्लो अँड वी कॅन फाइंड द व्हॅल्यू ऑफ F, coefficient of friction, by using this formula. F is equal to 16 upon RE. Okay, so this is the coefficient of friction. Sometimes they also use the term capital F. This term is used for friction factor. Friction factor. They are related to each other. Capital F, that is friction factor, is equal to 4 times of the coefficient of friction. Okay. जर friction factor त्या ठिकाणी दिला असेल, then this formula will become 16 into 4, that will become 64 divided by RE. Okay, now in this formula this R, जर या ठिकाणी 64 असेल तर हा जो F आहे, this F will be called as friction factor. Okay, जर इथं या ठिकाणी 16 असेल, then this F will be called as coefficient of friction. So this thing we should know, we should keep in mind. So first of all, write down this title, then write down this formula. Also you can note down this friction factor, relation between friction factor and coefficient of friction. Okay, and then you can also note down this formula. Sometimes in examination they may give the different they will ask the MCQ type question on based upon this formula. For the viscous flow through the circular pipe, what is the relation between coefficient of friction and Reynolds number? So they will give the different option. Option A, F is equal to RE divided by 16, or F is equal to, they will give here 64, or anything value they will give here. If they give 64 here and in question, then you have to become cautious. Okay, म्हणजे हा पण फॉर्म्युला दिलाय आणि हा पण फॉर्म्युला जर दिला असेल 16 अपॉन RE, ऍट दॅट टाइम या दोन्ही पण व्हॅल्यू त्या ठिकाणी बरोबर आहेत, पण क्वेश्चन मध्ये विचारले काय तर आपण त्या ठिकाणी पाहणं गरजेचं आहे. जर क्वेश्चन पेपर मध्ये त्या ठिकाणी कोएफिशियंट ऑफ फ्रिक्शन म्हटलं असेल, कोएफिशियंट ऑफ फ्रिक्शन म्हटलं असेल, इन दॅट केस वी शुड चूज दिस ऑप्शन. ओके, जर त्या ठिकाणी प्रॉब्लेम मध्ये फ्रिक्शन फॅक्टर म्हटलं असेल, देन दिस ऑप्शन विल बी द करेक्ट ऑप्शन. ओके, सो while attempting the question, we should be cautious about the name, what is mentioned there, whether it is coefficient of friction or friction factor. Okay, so this thing we should keep in mind. So have you written this thing, written this formula in your notebook, title and formula? If you have not written, do it, write it now, do it first. Once again, I will write here for the friction factor. There was a call from university regarding the question paper setting, so that's why I could not. I have to attend it. So, yes, we were talking about this friction factor. I have written this friction factor. Capital F is equal to 4 times small f. Sometimes this f, instead of f, they write f dash. Some author they use f dash title there for coefficient of friction. So here you can note down this formula like this also. Friction factor F is equal to 64 divided by RE. Okay. I think all of you have written this formula, and we will go toward the next title. Flow of viscous fluid between two parallel plates. ओके, जर दोन पॅरलल प्लेट्स असतील आणि त्याच्यामधून जर लिक्विड फ्लो होत असेल, त्या केसमध्ये शिअर स्ट्रेसची डिस्ट्रीब्युशन कसं असेल आणि व्हेलॉसिटी डिस्ट्रीब्युशन कसं असेल, ओके, त्याच्या संदर्भात या ठिकाणी आपण बघणार आहोत. सो हिअर नाव, इन्स्टेड ऑफ गोइंग फॉर द डिटेल्स ऑफ द डेरिवेशन पार्ट हिअर, let us write down this, draw the diagram and write down the equation directly for the velocity distribution. Okay, so write down the title first. Flow of viscous fluid between two parallel plates. Flow of viscous fluid between two parallel plates. Now here, these both plates are fixed plates, upper plate and lower plates. Both plates are fixed. Direction of flow you can see there. And the distance between these two plates, we can call this as the thickness of the plate. This is the T, denoted by letter T. This is the fluid element that has been considered for the derivation purpose. U is the velocity at which this fluid particle moves. And this velocity distribution is given by this equation. U is equal to minus 1 upon 2 mu del P upon del X into T y minus y square, where this T is the thickness of the plate or the distance between these two plates, T, and y is this distance of the fluid element, okay, from this particular one side of the plate. As we go in upward direction, so value of y, it will go on decreasing. So this value, what is going to happen? This will go on increasing, and as this value of y go on increasing, what is going to happen? This total value, it will become smaller, and not smaller, larger. It will become larger because this small हा मोठा झाला म्हणजे हा काय होईल, overall हे होईल, and this minus sign is there. So you can see in the diagram how the velocity of velocity profile will takes place. It will be similar to the velocity profile of the circular pipe. If you look at this, see, again it is a parabolic shape curve for the parallel plates, because equation is the power of 2. So y to the power 2. So it is again parabolic curve, and you will observe the velocity profile like this. Velocity distribution, it will look like this, right? And this is the shear stress distribution, and this is the equation for shear stress distribution. Tau is equal to -1 upon mu del p upon del x into t minus 2y. So we have to by heart all these equations. ओके, कोणकोणते इक्वेशन आपल्याला पाठ करायचे? इक्वेशन फॉर जे विस्कस फ्लो थ्रू द सर्क्युलर पाईप, त्यातले इक्वेशन्स जे आहेत 3-4 इक्वेशन ते आपल्याला पाठ करायचे. आणि यातल्या परत विस्कस फ्लो बिटवीन द टू पॅरल प्लेट्स, यातले पण आपल्याला हे इक्वेशन पाठ करावं लागतील. वेलॉसिटी प्रोफाईलची इक्वेशन लिहून झाली का सगळ्यांची? In the above equation, mu, del p upon del x and t are the constant, and here it means u varies with square of y, hence equation is the equation of parabola, right? So we will get a parabolic equation for this velocity profile. Next, write down shear stress distribution. Shear stress distribution. Write down this equation and draw the diagram. Velocity distribution and shear stress distribution across a section of parallel plates. Is it over? See, next equation is regarding the shear stress at the plate. So tau is equal to, when we put y is equal to t, okay, y is equal to t by 2. Shear stress is 0 when y is equal to t by 2, means at the center, and that is at the center line between the two plates. Maximum shear stress is given as, so this is the equation for maximum shear stress. Ratio of maximum velocity to the average velocity. So we have seen the relation between maximum velocity and average velocity for the viscous flow through the parallel plates, viscous flow through the pipe. So what was the equation that we have seen there? We have seen that u max is equal to twice of the average velocity. So maximum velocity is double of the average velocity. But if you see here, for the viscous flow between the two parallel plates, this equation is different. It is 3 by 2, or you can say 1.5 times. Okay. So note down this equation. U max is equal to, you can write this equation like this also. U max is equal to 3 by 2 or 1.5 times of the average velocity. U max is equal to 1.5 u bar. Next equation is for the drop of pressure for a given length of a pipe, P1 minus P2. So there also we have seen the same type of equation. Instead of T here, there was D square, right? As these are the plates, not the pipe, so the distance between them, which is represented by letter T, it has been used there instead of diameter D. 12 mu into u bar into L upon T square. If HF is the drop of pressure head, then this we have to add rho z. We have to divide both side of equation by rho z. So this will become pressure head, difference of pressure head. This is the pressure difference, right? If you divide it by rho z, it will become pressure head difference. Next, now let us solve the problem based upon this parallel plates. Okay. Is it over? To have you written all of you the equations, or anyone has remained? Note it down quickly. Is it over? Let us solve the problem now. Calculate first the pressure gradient along flow. Calculate first the pressure gradient along flow, comma, second, the average velocity, and third, the discharge for an oil, of viscosity 0.02 Newton second per meter square, flowing between two stationary parallel plates, flowing between two stationary parallel plates, 1 meter wide, 1 meter wide, maintained 10 mm apart, maintained 10 mm apart. Full stop. The velocity midway between the plates is 2 meter per second. The velocity midway between the plates is 2 meter per second. So let us first of all write down the given things. Viscosity is given. Width of the plate is given. H is given, distance between plates. H किंवा T हे आपण या ठिकाणी नोटेशन वापरू शकतो. या ठिकाणी H वापरलं. 10 mm or 0.01 meter. Velocity midway between the plate, that is maximum velocity. Maximum velocity कुठं असणार आहे? दोन प्लेटच्या एक्झॅक्ट सेंटरला या ठिकाणी मॅक्सिमम वेलोसिटी असेल. सो वेलोसिटी मिडवे बिटवीन द प्लेट्स मीन्स u max, right? It is 2 meter per second. Then pressure gradient. So let us first of all find out pressure gradient. Pressure gradient आपल्याला काढायचं आहे. Pressure gradient along the flow. How it is given? Del P upon del X. Means how pressure is changing along the this direction, whether it is decreasing or whether it is increasing. Initial pressure minus final pressure, you will get the pressure gradient, right? So what is the equation? We have the equation U max is equal to minus 1 upon 8 mu del P upon del X into H square. U max is equal to minus 1 upon 8 mu. I think this equation we have not come across this equation. So please note down this equation. We have not written this equation here. U max is equal to minus 1 upon 8 mu into del P upon del X into H square. Now here, put the values of H, mu, H max, U max, and rearrange the terms to get the value of del P upon del X. And you get here the del P upon del X is equal to minus 3200 Newton per meter square per meter. So there is a decrease in the pressure, that's why a negative sign you can see there. Average velocity, how we can find the average velocity? U max is equal to, we have seen this equation, U max is equal to this equation, 1.5 U bar, right? So what is 1.5 U bar? You already have found here, you can see here. U max is equal to 1.5 U bar. Okay, so if I take this 2.5 here, it will become in denominator, and we can write this equation like this also. U bar is equal to U max divided by 1.5. So U max is known to us there. So put that value of U max. U max is given in the problem, but directly they have not mentioned that U max like that, but they have mentioned that it is the velocity at the midway. So velocity at midway is nothing but it is maximum velocity, that is U max. So 2 divided by 1.5 will get 1.33 meter per second is the average velocity. Okay. Then अजून काय सांगितलं काढायला? The average velocity of and the discharge for an oil of viscosity 0.02 Newton second per meter square. So next option is to find question is to find discharge. So for the finding the discharge, we have the equation Q is equal to area into velocity. Okay, so this velocity is nothing but it is the average velocity. We can write like this also. Area, how to find out the area of the plate? That cross section. For that we will require the width of the plate, and then we will require the distance between the two plates, right? So this is the area of rectangle actually. Here this is the H and this is the B, right? So B into H, area of the flow, is equal to B into H, that is area, into velocity. You will get, put that value of B, UH and U in this equation, and you will get this is the answer. U is equal to 0.0133 meter square per second. In this way, we have to solve the problem. There is another problem here. So before moving ahead, all of you note down this problem in your notebook. Is it over? We will solve the next problem here now. But let me confirm from your side whether this problem is over or not.
Yes, sir.
Okay. Let us solve the next problem. Water at 15 degree flows. Water at 15 degree flows between two large parallel plates at a distance of 1.6 mm apart. To stop, determine first the maximum velocity, second pressure drop per unit length, and third the shear stress at the walls of plates. Shear stress at third the shear stress at the walls of plates if average velocity is 0.2 meter per second, viscosity of water at 15 degrees Celsius is 0.01 poise. Viscosity of water at 15 degrees Celsius is 0.01 poise. So first of all, let's write down the given things. Distance between two parallel plates is given, that is h is equal to 1.6 mm. You can write it as 1.6 into 10 to the power minus 3. Then mu is given, viscosity 0.01 points divided by 10 to get in Newton second per meter square. U bar is equal to average velocity is given is 0.2 meter per second. Maximum velocity, we know that first point is to find out the maximum velocity. So U max is equal to 1.5 U average. U bar is the equation that we have written. Use that equation to find this maximum velocity. 1.5 into u bar, that is 0.2. The pressure drop is given by equation P1 minus P2 is equal to 12 mu u bar h L divided by h square. Put that values in that equation and you will get P1 minus P2. L is equal to, now here it is asked to find out per meter per unit length. So here the value of L, we will put L is equal to 1. Okay. So you will ask, sir, where this, why this L is not taken here? It is taken, but it is taken as 1 unity because it is asked to find out pressure drop per unit length. To doing calculation, you will get the answer. Shear stress at the wall tau 0 is equal to minus 1 upon 2 del P upon del X into H. Is it over? So this is the end of the viscous flow. Viscous flow च्या आपण या ठिकाणी theory as well as problem या गोष्टी या लेक्चर मध्ये कव्हर केलेले आहेत. So those students who have remained to solve the problem, do it first. If you get the answer, correct answer, put your answers in the chat box. I will take your attendance now. Okay. Only two students have put their answers in the chat box. What about other students? Why but you have got their 0.7499? Which value is this? Okay, many students have put their answers in the chat window. Those students who have solved the problem, they can leave the session. I have taken your attendance. I have taken the screenshot of your attendance, so don't worry about presently. Okay, is it over? Tell you that you can leave the session now. In the next lecture, we are going to see the turbulent flow. Okay, and theory regarding it. If you are having any doubt, you can ask the question. Otherwise, you can leave the session. Okay, shall I close the session now?